Good morning to the guests and the participants who are attending this webinar hosted by School of IT as a part of webinar series Oro University. So we have with us today Mr. Rajan Mistry. He is going to speak on use cases of machine learning in financial services. So Rajan is born in a spiritual family in Valsad, Gujarat. He was inclined towards spirituality since childhood. However, he has been more avid follower and spiritual since last 5 years. He has completed his masters in IT from University of East London, UK. He has worked for companies like Tenzing, Teradata and TCS in for 5+ years, and since last 10 years, he is working with Barclays Bank, Northampton, United Kingdom. Rajan is part of a credit decision and sanction team who are responsible for building customer acquisition platforms for unsecured lending products like loans, credit cards, and partner finance. So this was a small introduction about the guest we have today. So over to you, Rajan. You can start your presentation.
Thanks, Anshu, and thanks Oro University for giving this opportunity to share my experience and knowledge on this topic. Warm welcome and good morning, good afternoon to everyone, wherever you are. So I would like to share some of the basics of what machine learning is, and then how machine learning is being utilized into the financial industry. So some of the use case what I'm going to share is not only going to be used by the financial industry, but I mean you can use that into any of the journey where insurance or any of the lending journey, different products would utilize them. So nowadays, I mean, because the trend has changed, where like to minimize the manual effort, minimize the monotonous task, and trying to do something automatically, and that's where the machine learning comes into the play. So before I go into my presentation, it's just a disclaimer. There's a lot of content and the documentation I have shared on this webinar, which is coming from the lot of different websites and data agencies and bureaus and all. I'm not trying to market any tools and technology here. I'm solely using this content for the knowledge and educational purpose. So please don't quote or refer these anywhere else. It's just for sharing my experience and sharing the knowledge around this topic. The difference between these different, they think that data science and artificial intelligence and machine learning is all the same thing. And then now the new piece which has come in, which is deep learning. Am I audible, by the way?
Yes, you are audible. I'll let you know if anything goes wrong.
Okay, thank you. Okay, so basically let's start with the data science. So data science is nothing but let's say if I talk about a layman's language, it's nothing but it's studying the data, understanding the data, and then deriving the different insights from the data. So basically what you extract from the data, how you utilize that data to make a better decisioning, to make a better outcomes, or to improve the experiences. So that's all about data science. When it comes to artificial intelligence, is about intelligently human processes it transferred from a human working doing to the machines. So like you enable machine to take some of the decisioning, you enable machine to do some of the tasks which are done by the human. So that's nothing but artificial intelligence. Now coming to the machine learning. So machine learning is nothing but a subset of artificial intelligence, but what it does is empowering computer system to use the learning from the past, use the learning from the previous record set and data sets, and then enable that machine to take the predictions, take the decisions, or make some work executions for you. That's all about machine learning. So you can use that methodology in any of the industry. It's not something that it's only used within the IT or IoT or within the financial industry. Anybody can utilize this. So I'll give you a typical example. So combining artificial intelligence and machine learning. So if you go to departmental store like a DMart or a Reliance Mart or any of the big stores, what they do is they assess the data and they come up with a decisioning that if I put cornflakes near to the milk, it's more probable that people buy both of these items together. And that's how they derived this intelligence, because by learning the data that they assess the different transactions by the customer, and then they come with the understanding that if you put these items near to each other, people tend to buy these more. Okay, so we'll go into the details about this topic. Deep learning is nothing but a further subset of a machine learning. So when you have a structured data set, when you have a known data set, you work on a machine learning. But when you have a unstructured data, when you have a huge amount of plethora of a data, and you want to do a specific derivation from the unstructured data, unlabeled data, unknown data, and then you have to delve deep into that subject, then you go into the deep learning. So the kind of example is you can't. So machine learning is all about predicting something from the known data sets, the structured data sets. You know what's going to happen. You know what are the probabilities. You know what are the different data sets look like. But when it comes to the deep learning, you don't know. It's something like completely unstructured. You can't think of a scenario. So let's say you're driving a car. Can you predict the scenario? Let's say you're on a crossroad. It could be like your signal could be red, your signal could be green. There could be vehicle coming from different places. So every day is a different traffic, and every day you have a different scenarios. So every day you have unstructured traffic. So the likes of Elon Musk and the Googles and all these people, when they are trying to develop this driverless car, they are trying to use this deep learning, because you may face any kind of a scenario when the car is automatically driving itself. You have to assess the data, unstructured data, the objects, the road, route, the surrounding, assess that, and then we have to take a decisioning that how the car will be driven. So that's more about the deep learning. Okay. So now delving deeper into the what data science, AI, and ML and all about. So a lot of people call themselves, I'm a data scientist, I understand data, I can delve deeper into a data, I understand a lot of things around the machine learning. But just to clarify that, I mean, a so-called data scientist, a person who is trying to wear a hat of a data scientist, has to understand a lot of aspects of it. So first of all, the individual has to be a domain expert. So let's say if I want to derive data about some banking insights, I cannot say I'm a banking expert. I can be an expert in one particular domain. So my particular domain is credit risk. So if you ask me about machine learning models around the credit risk, I can delve deeper into it because I have a domain experience on that topic. Then after applying the domain expertise, I would apply what kind of data I have, what kind of analysis I have done, how do I process my data, how do I derive different data sets or result set out of it, how do I do a machine learning model out of that, and then I combine all together analysis using the different tools and technology, the underlying platform infrastructure, and then I come up with the output which I can predict, which I can apply, which I can kind of do into the actionable items. Then it is more about the combination of a data science versus the artificial intelligence versus the machine learning on particular topic. So data scientist is a very, very wide field. You got to understand a lot of aspects of data. You got to understand a lot of aspects of the algorithm. So your maths has to be really clear. You need to be visualizing the data. You need to be analyzing the data, and then using that analyzing power, using that mathematical or statistical knowledge and experience you have, you put that instruction into a machine learning kind of a model, so that machine automatically starts taking the decisioning or actions based on the inputs you give or the program you write. Okay, so now I'm kind of coming back to the financial services. So because the machine learning, deeper learning or artificial intelligence is all about data. So everything starts with data. Unless and until you don't have a data, you can't make any kind of a machine learning model. You can't make any artificial intelligence. You can't do a deep learning. So you got to have a huge amount of mammoth amount of data before you start any kind of exercise where you want to kind of articulate a problem statement into a automatic machine learning model or a artificial intelligence scenarios. So for a financial services, we collect data from a lot of sources. So the internal sources we have is all our internal rating systems, our treasury systems, our HRMS, our the all the customer information, which is like all the customer who are on the current account, savings account, loans, credit cards, the equity accounts. Then we have the core platforms, so where we record all the customers, their transactions, their products. So there is a huge amount of data sets what a bank has it on its own by the virtue of the different product they sell or the customer details they have collected. At the same time, a bank also buys a lot of data from the external sources. So the external sources, like the main external sources is the credit information companies, which is nothing but the CRAs, credit reference agencies. So typically, I think in India we have CIBIL, CRISIL, Experian, Equifax. Those are the bureaus we buy data from. Similarly, in UK, US, the main bureaus are Experian, Equifax, Callcredit, TransUnion. So this bureau collect data from all the banks. They also collect data from all the financial institutions. They also collect data from your central bank. So for India, it's Reserve Bank of India. For UK, it's a Bank of England. So they collect data from everywhere, and they have a very, very rich data set. So if a bank wants to make any kind of a product offering, if a bank wants to onboard a customer, bank wants to do any kind of a business, there is no way a bank can do that without collecting information about that customer or about financial market from the credit bureaus. So anytime a customer applying for any kind of a product, they have to assess their customer using the credit bureaus. So that's how when you go and typically apply for a credit card, loans, or any of the lending products, where you don't have to give any collaterals, unlike a mortgage and the other expensive product. But let's say you go and apply for a credit card, you go and apply for some kind of a small loans or some kind of a product loans, which is nothing but a Bajaj Finserv kind of a loan. You want to buy furniture, you get a loan from Bajaj Finserv. What they do is they look at the customer data, they look at the credit bureau agency's data, they collect all your transactions and financials from the bureau, and then they have their own scoring and assessment mechanism before they offer you a product. So the credit reference agency is a very key element in the financial sector. Then apart from that, we also collect data from public and semi-public sources and the other corporations. Like Indian government, we collect a lot of data from there. A lot of auditing agencies, we collect data from there. We also collect a major data from the internet and social media. So if the customer is applying for a product, so if customer is not known, that his or her profiles or his or her presence on the digital media is being assessed. So just to give you an example, so at Barclays, how we collect data. So we collect data, we almost buy 6,000 attributes from credit reference agencies. So 6,000 attributes about 20-25 million people. So for each individual, we have some 6,000 data item collected by bureau that we buy, so that whenever a customer or a prospect applying for a product, we can assess that individual against that data attributes and make a decision. Okay, so now the digital and social media data, people will be wondering how this data is collected by banks. So we don't collect this data, but there are DMPs. So there are central agencies. What they do is, based on your behavioral pattern, the kind of a data you browse on your mobile, your iPads, your computers, they keep collecting data. So this central agencies, they collect data, and then they kind of put data into a particular domain, the sentiments, the behavioral pattern, and then they sell this data to different financial institutions. So whenever a customer is being assessed, we also look at the behavioral pattern, the social media pattern of that customer to make the decision. So, I mean, in this world, every individual is being assessed. So I don't have a bank account, I don't have anything, but still that individual would have a lot of data because he or she would be using mobile, she would be using some digital platform. He would she would be on a government platform for a PAN card or a Aadhaar card or any kind of a card you have. All these data is being collected, and that is being used for the making a offering or a feedback or a decisioning of a product. Okay, now, so this is nothing but going further into the previous slide. So if you look at the this particular section of the slide, where the kind of data we collect from different sources, what all data is collected, there's a huge amount of mammoth data collected on a day in day out basis. And typically IT system, what they do is they collect data from all the sources, they put that into their raw data warehouses. From raw data warehouses, they take that data onto the data marts. Data marts is nothing but a specific data sets clubbed together, and from the data marts it goes onto the different systems for a different reporting purpose. It goes to a marketing team, it goes to information business team, and then they assess that data, process that data, and then make the insightful outcome which can be utilized by the business. So now if you come to the bottom of the this particular slide, so basically, in a nutshell, the financial services would collect data, they would process that data, and then they would process that data and come up with the actionable insights. So I'll come in a minute on what does the actionable insights mean. So before we go into this, I think let me share this. So basically, let's say if we are talking about a customer acquisition or any firm who is trying to acquire more customers, so basically what they do is they look at the different kind of data sets, internal, external, the bureaus and the government agencies. They look at the data and they create a demographic or a kind of a 360-degree persona of the customers. So they assess the customer using age, race, religion, family size, ethnicity, income, and all those parameters are being assessed. So now we have collected that data. If you look at the bottom of this slide, the kind of insights which is created. So based on the data, we come up with the insights on, okay, what is the age range of the customers or the age range of the people look like? What are the product we can target them? What are their pets? What are their religion beliefs? What kind of home they own? What kind of family sizes they have? What kind of education they have got, their employment status. So based on this segmentation, those people could have been offered with a different product, those people could have been offered with a different experience, different services. So based on this segmentation, every industry target this customer persona or demographic related data. So this is very crucial. So just a caution of notes, whenever you fill in any kind of a form, there is a tick box where you say, I am sharing my data, let third party use my data. You share data with banks, you share data with government. Lot of data is being churned and being utilized by a lot of companies to offer you a product or a service or experience. And that's how they segmentize the customer. They look at your spending pattern, they look at your different buying pattern, they look at your the ethnicity. So let's say you have Hindus have a Diwali as a festival. So during the Diwali festival, they would offer you a lot of product because of your religion and the beliefs, the kind of buying you do during the Diwali. So same for Western countries, during the Christmas, they offer a lot of product. That's why you have the Black Fridays and Boxing Days and all those kind of events in the Western countries, where they offer you a lot of sale and the bargain product during that period. Okay, so until this point, it's all about a basic. Now I'm going deeper into the how does the machine learning life cycle, how does the machine learning works. So before I go further, I mean, are there any question on the basics of machine learning or the data or anything of that sort?
We have a question. Can we predict the stock exchange related things through machine learning?
Yes, we do. Yes, we do. And then that's how, if I go further into my the slides, I'll share how the trading analysis or the equity is being assessed. So if you are onto NSTL or or a BSE, NSE stock exchange, or if you are following Dow Jones or any kind of a stock exchange in the world, the if you look at the share market, how it's going up and down, it's all because of the market sentiments. So if the government is announcing some FDI, it would change the certain pricing of the shares. If there are certain products being banned, then the share prices of that product is going down. So how is it impacting? So it's all market sentiments impacting your the company net worth, your company share prices. So it's all related, and within the fraction of second you see spikes, you see ups and downs within the share trading market. So that how it is happening, it's all because of the sentiments. So if somebody is really doing the intraday, or somebody is doing the futures and options, the typical call put in India, so how those ups and downs are happening, because the day starts in Singapore early, you have a sentiment coming from that market, it comes to the India, from India it goes to the Europe, from Europe it goes to the US. So by the time your stock exchange in India is closed, but there is a still active trading ongoing at the US market, and that's what the sentiments carry forward to again back to the Singapore, Australia, again coming back to the Asia, Europe, the cyclic pattern. So there are a lot of news, the outside agencies news, the government news, the people sentiments, something went wrong with the companies, something went wrong with a particular sector. So if you look at the current COVID situation, so the medical equipments and all that is booming, and the prices are increasing because of the sentiments, because of the buying, and then that's how the share prices will go up. And that is where the companies would try and apply the models there, and they would apply that model to derive the result set, so that they can make a better decision for the future. Okay, any other question before I delve deeper into this?
No, we don't have any other question for now.
Okay. So now, typical machine learning or a machine learning model life cycle. So machine learning model, this is nothing related to banking or financial services. Any typical machine learning model you want to implement for a marketing or information business, or for a automobile, for any other matter, you typically go through this typical life cycle of a machine learning model. So basically, you start with a business case, or you start with a requirement. So what are you trying to achieve? What are you trying to automate? What are you trying to predict? So you come up with that. So let's say business says, I've got this particular process where so I'll give you an example from automobile, because I'll have a number of examples from the financial industry. So you look at the BMW car, or you look at the Audi car, they come with a very jazzy and fancy features. Okay, so let's say the BMW wants to, it already has a feature which is active pedestrian. So what it does is, anybody who's coming into that to 180 to 70 degree of a visualize, gives you a notification or a message or a warning. There is a how they have implemented this feature. So they have they have come up with a requirement that rather than a driver identifying somebody is trying to cross the road, somebody has appeared in front of a car, they would say that let car make that decision, that if there is a human individual appear in front of a BMW car, it would send out a warning to a driver or to a car, and it would blink, it would give you a buzz. So what they do is they assess the data. So in terms of a data, they would assess what does the typical human look like. You'll have a particular persona or an image of a human being. It could be a one human being, it could be a multiple human being. Then you have come up with a lot of XY axes, the image plotting, and a lot of so I'll not go into the machine learning details of it, but then you cleanse the data. So let's say typically when a machine learning example starts, whenever use case happens, so use case is a very specific, I want, then you collect data around that requirement, then you cleanse that data. So typically in a financial industry, what we do is let's say if I want to do a probability of a default, how likely a customer is going to be a defaulter. We collect almost 2 to 3,000 attributes of a customer. Then we cleanse that data, because not all the data attributes are relevant whether customer is going to be a defaulted or not. So then from out of 2,000, 3,000 attributes, we come up with a very specific, with a data cleansing exercise. There are different methodologies and logic behind how the data cleansing happens. It's not like I'll just pick and choose what attributes I'm going to use. There are different methodologies around data cleansing as well. Then you do a data exploration and analysis on that data. So let's say out of 2,000, 3,000 attributes, you have come up with the attributes of like say 500 attributes now. So you have made sure that these 500 attributes are meeting what my business case or what my requirement look like. So out of those 500 attributes, you then further go into a data modeling. So that's where you apply different machine learning model algorithms, which is typically you apply for a classification, your supervised learning, your all the algorithms, gradient boosting, and the random forest, and all those kind of algorithm you would try and apply here. And then what you do is then you do the validation. So the validation is nothing but you have a previous result and you also have the current data. So you compare between a previous result and the current data. Then you try and validate whether my output, which is coming from a model, is correct or not. Once you are satisfied with the output, then you deploy that model into the actual system. So-called feature we started with, that I want to identify whenever a pedestrian or an individual crosses the road in front of my car, I want to create an alarm. So that's where you started collecting data, you cleanse the data, you analyze the data, you create the model, you have identified that I want to identify this kind of objects, you validated that object using some kind of a proof of concept, you do put that into the reality, and once you implement that feature into a car, and that's where it keeps on creating the insight from that feature. So now once you deploy that feature, the job is not over yet. So after you deploy that feature into a particular, let's say in the BMW, you implemented a feature that I want to identify a pedestrian. So once you implement that feature, they keep on monitoring that feature as well. It's because whenever you come up with a new model of BMW, they have to enhance that feature, because sometimes if the customer is coming from the side edge, he or she may not be identified, or customer is coming from the front at a very rapid pace, you are not able to identify that. So those kind of a data element you have missed out on all your exploration phase or a modeling phase. You keep on evaluating your model, enhance your model, and then keep on re-implementing that model again and again. And that's how kind of you evolve on your machine learning model. So if you look at the typical life cycle, so you collect a data set, you do a data cleansing, you do engineering on top of it, which is typically algorithm you apply on that data, which is like the decision tree or a random forest or a gradient boosting and all those kind of algorithm. You choose what is the perfect output which is near to the reality. You apply that model here, algorithm here. Then you have a training data set, you have a new data set, you compare these two data set, you understand your algorithm, because the training data set is a kind of a manual data set, and then you have a new data set which is nothing but coming from a model. You compare these two data set, you again train your model, then you have a typical scorecard mechanism. So scorecard is typically a XYZ or a three-dimensional scoring mechanism created on a particular feature. So let's say if I want to achieve this particular attribute or feature, I would create a scorecard for it, and then that scorecard I will keep on comparing based on my output what I am getting from the model. So I train my model, I compare my model, I compare that against my score, and then I evaluate my model, and that's how I keep on doing it until I want to kind of satisfied with my model output. And once I'm satisfied with my model output, I'll go and implement that model. So it's nothing but I think most of the plethora of information available on your Udemy and Udacity and all those online educational platform, and you must be like a lot of people are learning that on the online portals and all that. So I mean, just trying to highlight what all platforms and the the technology tools and technologies being utilized around the machine learning and the artificial intelligence for say. So you start with the data platforms. So that's where I think the typical data platform is nothing but your underlying database. Now, when it comes to the machine learning, artificial intelligence, you are not talking about a typical RDBMS. Here you are talking about a NoSQL database, your unstructured database, a documentum database. That's where you come into a picture of Hadoop, Postgres, MongoSQL, DocumentDB, those kind of the database where directly work with the underlying file system. The humongous amount of a data where typically RDBMS is not able to cater to the result. That's where you use typically the MongoDB and Hadoop kind of databases, which is a NoSQL or a DocumentDB kind of a database. It's not having a specific table structure there. So you use majoritarily with the machine learning. You see MongoDB and Hadoop a lot of utilized there. You see Spark and Scala clusters being utilized for the data platform. And then from the ML tools and AI tools perspective, you have your plethora of libraries available: scikit-learn, XGBoost, you have Random Forest, you have TensorFlow. So the number of libraries, the Python libraries, you have a Dask-Kit, and there's a huge amount of tools and technology available there as well. You have a data exploration and visualization tool. You have a lot of ClickView and Tableaus, and where you can visualize data. A lot of Python libraries also offer the visualization. There's a tool called Orange coming from Anaconda Enterprise, which you can utilize to visualize data. Then talking about data ingestion, because you have a lot of tools, but you have to keep on ingesting data from a different data sources. That's where you have a lot of data ingestion tools which you utilize. You source data from different sources. You keep on ingesting them into your data platforms. Then you have a lot of tools to develop the machine learning mode. So you have one side you have a platform where you store data. One side you have libraries where you can write the algorithms. But you need to have an IDE where you can write the algorithm. So that's where you have a Jupyter notebook and the R and all those stuff where you can write your machine learning models. And then you have different languages within the Python, Java, C#, R, where you can write the this particular algorithm within this IDE and make the meaningful, actionable insights from that. So I'll pause here. Is there any questions? Because now I'll dive deeper into the how financial industry work on a different machine learning model.
We have few questions. So the first question is machine learning and deep learning different things?
Yes, both are different. So machine learning, as I said, I mean, if I have to take back on the first slide. So the machine learning, you have a known data set. So let's say, I'll give you my typical example. Okay, so within the financial industry, so let's say an individual goes and apply for a credit card or a loan in a bank. So right, so let's say you go to HDFC, you go to SBI, you go to ICICI, you go and apply for a credit card or loan. So likewise, you have thousands of branches across India. There are thousands or millions of people applying for a loans or credit card. Okay, now you know that what all data you collect from a customer, how you process that data, and then how you come up to a decision whether I want to offer a credit card or a loan to a customer or not. So this is all known process. Now what happens is you have a huge amount of staff in the branch who is collecting this data from a customer. They're asking you to fill in the form, or you go online and apply for a card or loan, or you go onto a website, you go onto a telephone and apply for a card or loan. So be it any kind of a channel, but the bank would collect a similar amount of a data from a customer. Then they would collect data from the bureaus and agencies to assess whether shall we give the loan or credit card to a customer or not. Now what happens is, what you see in the branch, that is a very, very minimal staff. There is a huge amount of back office staff. For back office staff, there is a huge amount of staff called underwriters. So now a lot of time what happens is the underwriter has to assess your application. So a lot of time people have different scenario. Somebody has defaulted a loan, somebody has not paid the credit card payments on time, somebody has some different is not paid your mobile bills on time, or you have some kind of an application goes to underwriter. It goes into a 3 phases: accept, reject, or refer. So Now, what underwriter does is, why the application has went into a refer, because there are some parameters which are not positive parameters for a customer, and that's where they will assess your case. They'll refer the data from bureaus and different agencies, and they'll take a decision. They'll take a calculated risk that whether we should offer a product or not, and that's where the machine learning will come in place. So rather than having thousands of underwriters assessing your application, they would apply a machine learning model there. So the model, what it would do is, it will refer the data from last 3 to 5 years and saying that by these kind of attributes, if a customer has, we typically approve the product. If this kind of a negative parameter a customer has, we typically reject the customer. Okay, so that's where you, using this data set, you apply an algorithm which will automatically take a decision whether to approve a customer. Okay, so the deep learning, as I said, I mean, it's unstructured data. The machine learning is a structured data. That's why the deep learning is a subset of machine learning, is different than what machine learning is.
Okay, so next question that we have is from Mr. Santosh. Machine learning in case of medical field. So he wants to know, if we are predicting something, then it should be probabilistic value. How safe is it to rely on AI in the field of medical field? He wants to know about it.
So I think medical field, I mean, I'm not a medical domain expert, I'm a banking expert, but I would still say medical domain also, they collect a lot of data. So they collect data from your the blood report, they collect data from your biopsies, they collect data from the patient histories, they also collect data from previous patient histories. They also collect data from your cells. So within the cells, you have different parameters, RBC and hemoglobins and your lipid profiles and liver profiles, and so huge amount of data is there. Now, how these parameters work with each other to derive the meaningful learning. So if you look at it, so a typical example of, let's say, when you get a fever, you get a coughing, you get a fever, you get a body ache. So what kind of a cells changes within your body, and that is all being assessed. And that's how, whenever you want to implement any kind of a medicines, or whenever you want to apply any kind of a learning using that data, that's how they understand the pattern of cells. So that's how, I mean, even within this COVID-19 era, they have understood, right? The pattern is changing. So the first, it started with the throat infection, then it started with the fever, then now it is like there are different symptoms being observed. So the virus itself is changing its pattern. It's changing its places from a different part of body to a different part of the body. So these are all being assessed using the data which is collected, and that's how the machine learning comes into a picture, that it predicts how my data sets. You must have seen a lot of graphs in the calculations on the news channels and medical sites, and where they say that the fatality rate is and the aged is higher. Now the fatality rate in the younger is higher. So all these is being data collected by the medical professions to come up with a machine learning model. So everywhere, I mean, machine learning is not like a industry specific. It can be used anywhere. Hello.
Okay, yeah. So we have a next question. If I want to make a trading app with showing predictions like others app shows, then how do I get live stocks data?
Okay, so I don't know how active it is in the open banking. So in UK, US, we have a concept of open banking. So open banking is nothing but you are supposed to share data with each other. So let's say if I'm an employee of Barclays, or if I'm a customer of a Barclays, I can still get data from HSBC, I can still get data from Lloyds, I can take data from the NatWest. Similarly, in India also, the open banking will kick off, where you are sitting in an application of SBI, or you are sitting in an application of HDFC, you would still be able to look at your balances from the other banks. I think it has started. Maybe I'm not sure how faster the rollout is in India, but there is a data insights for a customer. So now, previously they were sharing data only with the bureaus, but now it is everybody is supposed to share data with each other. So what happens is, within the trading, what happens is, you go onto a boat where you either use the ICICI, HDFC, or any of there are Zaveri and the Carvi and different kind of a trading platform. So what they do is, there are web services being published by the NSE, BSE, NSDL. So those web service, what it does is once you register yourself as a trader. So let's say if I'm a ABC Limited and I say that I want to host a trading platform, I would go and seek those web services access from the central platform. So I would go to BSE, NSE, NSDL, and I'll tell them that I need to assess all your web services where I can capture the stocks and trades, and I can allow my platform and I can allow users to come onto my platform and trade. So it's all a web service architecture where they collect they real time connect to the central platform, they collect data and then make the decisioning, and then that's how the customer is also assessing this. So a lot of people some people use HDFC platform, some people use ICICI platform, or some people use completely different platform, but all these platforms are, at the end of the day, they are connecting to a central platform which is provided by NSDL, BSE and NSE, and that's how the data is governed from a central platform. They have opened the web services which you can consume and you can predict, but it is illegal to kind of predict market sentiments and saying that this is what. So there are legal cases. So I've seen a case where like an individual was a insider trader. So what they were doing is, before the NSE or BSE publishes the value of a share, they were predicting those values and they were giving those tips to the customer, so the customer can make a decision whether I have to sell a share or buy a share. And that's illegal to do it. But a lot of people are selling it as a tips. There are legal business. People come work with the nuances and they give tips and saying that you can make profits and businesses, but I would not call it a legitimate trading. It's like you are trying to assess the sentiments, come up with a decisioning and saying that you buy share, sell share, you make predictions around that.
Okay, so next question we have from one of my colleagues. She wants to know, in what format should we introduce the course in business school, as a certificate course, as a class input, or as a module? What recommended duration? I mean, she wants to have basically a course in finance using machine learning. So
okay. So I think what I would suggest is, I don't think somebody is offering a course where like you can directly go into a machine learning, into a finance and try and apply it. Basically, all the techie people, they try and understand what the underlying technology is. I mean, I am also Indian, so I mean, a lot of time what happens is we always try to learn how does the Python work, how does the Spark work, how does the Scala work, how can I write a program in Python, Spark, R. We keep on learning around the technology, but we don't understand what is the use case of a technology into the business. So how do I leverage my tools and technology knowledge into a business? So if I have to apply these tools and technology knowledge into a business, I also have to understand some business domain expertise. So if you want to do anything into the machine learning or artificial intelligence or a deep learning, and you want to go into the financial industry, well, you'll have to take one domain within the financial industry, understand that domain, how does that domain works around that. So it's a more kind of a techno-functional learning individual will have to do. So if somebody is offering you a course where like they say, I also teach you a financial domain, at the same time I also teach you a machine learning, I really would be surprised if there are those kind of courses available in the market. But you'll have to understand both the things in a silos. So you'll have to understand how the machine learning, because that's a completely technology world, and then you have to understand the financial sentiments and the domain of the finance, and then combining these two and applying a use case. So when I go into deeper into how machine learning is applied in finance, then you would try and understand how the domain expertise is derived and how the technology expertise is derived, and then you combine both of these, and then you can go into that field.
Okay, so next question is, what are the algorithms which are popular and oftenly used for financial services tasks for predicting, especially stock prediction?
Hello.
Yeah. Next question is, what are the algorithms which are popular and oftenly used for financial services tasks for prediction of especially the stock exchange or stock prediction? Am I audible?
I'll not be able to. Yeah, I can hear you now. So I'll not be able to comment what a stock exchange prediction. That's where documentation. You can do image classification. You can do a customer retention. You can do a diagnostic. You can do a forecasting using the supervised learning. When is unsupervised learning? So that's where like you collect data from marketing, you collect data from social media, you collect data from a lot of discrete data sources, and then you try and understand that data and come up with a result set. So that's where the unsupervised learning come into a picture. And when it comes to the reinforcement learning, so which is like supervised, unsupervised combined together, then you have different set of algorithms. So all these three dimensions, it has an underlying algorithm. So if I say for one particular methodology, a lot of time when you are a data scientist, right, you understand that so when somebody is a really expert data scientist, so if I go with some kind of a data set, that data scientist is so much experienced and knowledgeful that data scientist can easily tell me, okay, you can go and apply this to a couple of algorithms and you will be able to derive the result set. But a lot of time what happens is, when you go with the supervised learning, right, let's say you compare data using the random forest, and then you start comparing with the boosting, and you also have the decision tree. Now you have three set of algorithm deriving three set of different data. What you have to do is, after deriving the data using the different machine learning algorithm, you have to compare that against the past results. So we call it, within the banking, we call it champion challenger model. So champion challenger model is nothing but a champion model is nothing but a, from last 3 years, 5 years, I know this is how market runs. This is how market behaves to the sentiments. This is how the share prediction happens. Because I have a past data that has happened. I've got a concrete data around that. Now, using that past data, I will compare that result against my model output. Once I compare my model output against the past data, whichever algorithm gives me the near result, I would go and apply that model. So it's not like there is no right or wrong answer here. You have to use multiple algorithms into the model. Then you have to. That's why I showed you, right. You have to train the model. You have to score the model. So unless and until you train and score the model, you would not know how accurate you are with your training data set to derive the model. Because you cannot say that I will go and apply the decision tree and I'm happy with the result. You never know, a random forest may give you a better result than the decision tree.
Okay, next question is, how can we manage fraud detection and prevention in banking field using machine learning?
Okay, so that's a very common model. I think we call it now, but I mean, banks been using those models for almost 20 years. So what happens is, whenever you go, I mean, I'll not go into a detail because I mean I will run out of time. But so the way transaction flows in, right? So whenever you go and make a transaction on the POS or a point of sale, or let's say you swipe a card at one particular terminal, you swipe a card at ATM machine, or you do a transaction online, all these transactions are put through a system. There's a very famous system called Falcon. What it does is it does the fraud detection. So it has a machine learning models. What it does is, first you have so let's say in a day, let's say you talk about one particular bank or one particular financial institute in India, you could have, let's say, 1 billion transaction. Now all these 1 billion transaction across the ATMs or POS machines is flown through a one system. That system will have some 10,000 rules applied against those transactions. Based on that rule, they do the data cleansing. After the data cleansing, they derive the result set. That result set is given to the model. That model would assess if somebody is spending. So I'll tell you some of the rules how the machine learning happens on the transaction. So let's say if somebody is spending 10 to 12,000 rupees a month, and suddenly he or she has spent 30,000 in that month, suddenly it will create a flag on Falcon system saying that the pattern has changed. Somebody has made a transaction in Mumbai, and within few minutes, same individual has made a transaction in Chennai. Not possible, right? So again, the Falcon system will create a rule flagging this transaction. Somebody is doing a transaction online at the same time that card is swiped outside somewhere in the same city. So there are different. So there are 10,000 plus rules on a transaction applied, and there are models running underlying to identifying the patterns of the transaction happening in the real-time world. Within that, it creates the cases. So a lot of times you had sometimes happens when you make a very huge transaction, you immediately get a call from your bank, right? These are like high fraudulent possibility scenarios where the bank believes that, oh, is the customer really made a transaction, or is there a fraud? Because it's a bank's responsibility to revert that money, right? So that's why from those billions of transactions, there would be a 500, 300 typical transaction would be going to the back office saying that immediately make a call to customer to find out whether there is a fraud or not. So there's a huge process around all the transactions. There are rule set being defined. There are models being defined on that transactions. It derives the insights. Those insights are continuously monitored by the back office people. And then, so because there are transaction volume is 1 billion, but the operations people or the back office people would be typically looking at the volume of 1,000. So I was waiting that you were going to ask some questions. I was waiting.
Okay. So it was like very quickly we can take these questions. Can we use deep learning in power plant for information?
Okay, so now
you are not audible. Yeah, I think there is some network disturbances at your place.
Yeah, can you repeat the question?
Can we use deep learning in power plant for information?
Deep learning can be applied anywhere. It's just that you have to understand what you are trying to derive. Okay, if it is, as I said, I mean, if you are really known use case, probably you go and apply a machine learning model. But if you really want to assess something at a very, very neural network level, probably you go and apply a deep learning there. It's not like, I mean, these are very generic questions. So I mean, it has to be what you want to derive using a deep learning. That is the question. So what do you want to do in the power plant? What is the objective you want to achieve? And that's when, based on the objective, you understand whether I want to do a machine learning or I want to do a deep learning.
Are you there?
Yes, can you hear me?
Yeah. So next question is, can we use, is it possible to apply machine learning for hedge and derivative transactions?
Machine learning can be applied anywhere. So that's why, I mean, Anshu, can I go into my financial slide so that then it will give a lot of insight to people?
Okay, great.
Yeah?
Okay.
Yeah. Okay. So can you see my slide now?
Yes.
Okay. So people are calling a machine learning buzzword for last few years, but banking is using the machine learning for ages. We call it a typical processing of a banking, how it happens. So these are the areas we've been actively using machine learning. Okay, so now let's go into the enhanced risk assessment model. So within the enhanced risk assessment model, what we do is probability of a default. Rather than me allowing my underwriter or a back office staff to make a decisioning and hiring thousands of staff, I leave that probability of a default functionality to a machine learning model, so that I can hire less operation staff and machine can take a decisioning or prediction. Similar way, impairment, delinquency, forbearance, operational risk, fraudulent transaction, we just talked about it, market risk, business risk. So all these areas we have machine learning models implemented. And there are different outcomes we want to achieve, different predictions we want to make on these areas. Similar way, customer profiling model. So we assess the lot of customer demographic data, identity and verifications, what channels customer are choosing these days more. So nowadays we don't opt for a later based applications. We don't opt to go to often to a branch. We want to do everything often online, digital channels. What kind of products customers are going more. So then a lot of models what we use in the upselling or a cross scaling. So upselling is nothing but a customer has 2-3 products from a bank. Now we want to sell more product to a customer. So that's where we start assessing a customer data and offer them a product. Cross selling is a customer has a loan. I would go and offer a credit card to a customer. A customer has a loan. I would go and offer a value-added product to a customer. So that is cross-selling to a similar customer. Then we also assess the kind of complaints received from a customer. Based on the complaints, we derive a lot of insightful data, and we apply machine learning model on top of a complaint data as well. A lot of feedback we receive from a customer, we apply machine learning model on top of it. There's a huge set of customer base which is HNW and influential. HNW is nothing but a high net worth. So somebody having a few crore in their account, somebody is a really influential. You have like a mayor or a corporator or a really senior individual having an account with your bank. So those kind of HNW or influential people, you have to treat them differently. So what kind of banking product you offer to them, and that's where you apply a machine learning models. And then you have a PAP. PAP is nothing but a publicly exposed person. So a lot of politicians also hold a bank account, right? Now you don't want to mess around with a politician. So there's a lot of algorithm applied on the politicians' accounts data. So nothing goes wrong with those accounts. So even if there is a minor negative parameters, but you still give a leeway to HNW and the PAP people, so that you don't have a reputational risk or a risk to going into the market where the news is exposed in the market by the senior people or the influential people. Then you have MS indicators, which is nothing but your marketing separations indicator. You have insurance products and trade finance. We apply machine learning. Now coming to the compliance and reporting model, there's a huge amount of processes bank runs on a day in day out basis. So we have KYC, which is nothing but I know your customer. We can keep, so you must be knowing that the bank keeps on asking for your details. Please provide me your KYC details and all. Then you have anti-money laundering, AML details. You have KYB, which is know your business. You have Sarbanes-Oxley standards, GDPR. You have payment card industry and data security standards. You have BCBS 239, IFRS 9. Then you have to bank also has to report back to the central bank. So in India, every bank has to report back to the Reserve Bank of India. In UK, we have to report back to the Bank of England. Then we have new kind of norms and standards coming into the market. So you have to keep on evaluating those standards. Against those standards, you have to keep on evaluating your customers and sentiments. So all these are done using machine learning. Then you have bureau updates. So a lot of time bureau says that there is a negative sentiments coming into the market. So based on the bureau input, we tweak our product. So let's say if there is a COVID-19 era now, so what bank would do is, if bank is conservative, what they would do is they'll increase the credit score. So the bank would say, typically I was offering a product if somebody has a credit score of 500, I was offering them a product. But now because of the COVID-19, a lot of people will apply for a loan. I would increase the credit score from 500 to 530. Now anybody who has a less than 530, they'll not get a loan. So that's the sentiments we receive from our markets, and we keep on taking a decisioning using these machine learning models. Then we receive data from Moody's and Fitch financial agencies. We have external auditors like Big Four, like PwC, KPMG, and all those. They provide us data, and we treat that data and apply models on that. We have a social media presence, like collecting a social media patterns, and we apply models on top of it. Life events, a lot of customers have their, like if you have a baby, you get married. So different events happening in individual's life, we assess that data. Market sentiments, the natural calamities, the employee fraud. So employee fraud is a classic example. So I mean, what happens is a lot of time you work in a bank, like say people working in a branch, what they do is they keep on looking at a customer data. Okay, so bank also assess this data. bank also assess that what employees are browsing what data, and why, if they are browsing unnecessary data of a customer, and they apply a machine learning model on top of that. Employment updates, resignation. So a lot of time a bank is a very standardized industry or a institution where it's dealing with a huge amount of money, it's dealing with a huge amount of reputational business, liquidity, market risk. So we have to assess our customer very diligently. So let's say if an employee, a typical employee resigns, what we do is we assess the data, saying that what that individual is doing on the bank data, right? A lot of time what happens is an individual trying, because I did not get a hike from my company, I will do a harm to my company. A lot of time what I'll try and steal a data, I will try and take a data out from here, and I'll take that into my personal mail drive, or I'll take that into my personal account. So all these behaviors are assessed, and we apply the machine learning models. What it does is machine learning model will create the predictions, and these predictions will straight away go to these line management or HR, saying that this individual has resigned. Now next 3 months is a watch period. Within these 3 months, if the individual is doing any kind of a transaction which is a suspicious, we'll go and tap, we'll disable the account, or we'll take action on that individual. Then we do a lot of data exploration. We also look at the employee sentiments. A lot of time when the bank gives the bonus, bank gives the hike, we assess the employee sentiments, how they are behaving, how they are feeling, and those sentiments are recorded, and then we apply model on top of it to understand how we can do better. So these are the plethora of area where we apply machine learning models. These are only few, there could be more, but I'm just trying to highlight everywhere you can apply machine learning model. And bank has been using this machine learning model for ages. It's just that it's a new buzzword into the technology world now. Okay, moving on to the, any questions here before I move into the actual specific use case?
No, please continue.
Okay, so one of the machine learning model what we recently applied, which is the document verification. So a lot of you will think that what's the big deal in this? So basically what we were doing is, whenever a customer apply for a product, we ask customer to share their payslip, we ask customer to share their bank account statement, we ask customer to share their the tax documentation and all, right? Now basically when the customer shares these documents, right, it is in the either you scan the document or you like input the data, but what happens is the back office staff has to go and verifies these details, right? Whether the customer has declared I earn 50,000 a month, and customer earning that 50,000 a month or not, verifying that from a bank account, verifying that from a tax statement, verifying that from a PAN statement. I mean, there's a number of things a back office or underwriter has to do before we offer a product to a customer. Now that's where we implement a machine learning model. So what we did is, whenever customer uploads pay slips or a documentation, we take that data, we put that into the machine learning model. What we have done is, so whenever you, let's say, upload a pay slip, right, your typical month pay slip look like what your net salary is, what your tax amount is, what your PF is, and all those elements. When you have a bank statement, you will have all the series of credit and debit transaction, your opening balance, closing balance, and all that. So what we do is we scan this document, we compare what is the salary, what is the employer, whether the salary is matching the payslip, whether the salary is the salary company is matching with the payslip what you have offered. We also try and assess whether the bank statement is valid or not. A lot of time what people do is they create a fake bank statement saying that, oh, I got a salary and this is what my bank statement is. So we assess that using a machine learning model. So we do a text track. There are a lot of open API where you can assess the data, how to scan a document, assess the document, come up with the insights saying that I've got then we come up with the confidence factor saying that I'm 90% confident the details provided by this customer is valid. So that gives a relief. So if I talk about my average operation staff has to assess 5,000 applications in a day. So let's say if we have 100 people, they are assessing 5,000 applications in a day, and if they have to compare these documents on a manual basis, is a mammoth task for them. So if we do the machine learning, probably they just have to look at the confidence factor. They will say, oh, if my confidence factor is above 80%, I'll approve all the customer. If my confidence factor is less than 80, then only I'll go and assess that customer details. So that kind of reduces a lot of work for my back office staff, the operation staff, and I can automate my landing journey using the machine learning. So this is a typical example of how machine learning gets implemented. And this is again a decision system. I think I'll I can go into detail, but are there any questions around any of this? Hello?
Yes,
Hello?
yes, no question.
Okay. Okay. Now we talk about on this slide we were talking about a risk assessment, right? So all these models what are created here, we are trying to implement that into a decision system. So basically what happens is when the customer applies, we put that customer through a decisioning system, and then we apply the models in this part. So let's say if I have to assess the customer data by assessing a probability of a default, or by assessing a delinquency or a forbearance model, I'll have that model implemented. So whenever I want to make a decisioning of that customer, whenever I refer a bureau data, whenever I refer a internal data, I will take that data, I'll apply that data to the model, I'll come up with a decisioning, and the decisioning agent will merge that input, my input data, my model data, my bureau data, and then it will make a decisioning automatically. So a lot of time, I'm not sure what's the status now in India, but a lot of time in Western countries, what they would like to offer is you go onto a site, you say I earn 50,000 rupees a month. My PAN card number looks like this. My Aadhaar number is looking like this, and now I want to apply for a loan worth of 500,000. Okay, 500,000 rupees. Now, the moment you submit the details, right, all this process starts. You collect data from bureau, you collect a lot of data from internal sources. If you have, you collect data from social media sources, and then you start applying these different models on top of data, and then you derive the result, saying that within the 30-40 seconds, customer gets a green tick mark on their screen saying that yeah, your product is approved, and probably within the same day or within a few hours you get a loan disbursed into your account. Now how this journey happens, it's a huge amount of exercise or huge amount of processing happens underlying. You collect data, refer bureaus, apply machine learning models, you apply different algorithms on top of that data, you make a decisioning, pass on that decisioning to a digital channel, and then digital channel displays the result to the customer. Once customer says yes, I am happy with the product, customer says I agree, please give me the loan, again the data comes back, you connect with the core banking system, you create an account for a customer or link the existing customer account, and then you disburse the loan to that customer. There's a huge amount of process. It's a very simplistic diagram to implement a machine learning model, but this is how you shorten the journey. So gone are the days where like people used to apply for a loan and they used to get a decision after 7 days or 10 days or 15 days. Now it's a rapid age where like the customer goes online, within few seconds they want to see whether I get a loan or not. With the apply card, they want to see whether I get a card or not. Previously it used to happen that you apply, then you have to wait because bank manually assess the customer, they refer the data to create the profiling of customer, and then they assess the data. Now everything is rapid pace. There is a lot of underlying processing, there is a lot of machine learning underlying, which allows system to take a decision. No individual is involved. Immediately customer gets the outcome, oh yeah, my product is approved. Any question?
Yes, Rajan. Rajan, we have a question. You were talking about some tools, so Mr. Amitesh wants to know which tool is most preferred.
Sorry, I didn't get the question. Can you repeat? Anshu,
You have talked
voice.
about the tools that were used for machine learning and detecting the customers. So a participant wanted to know which tool is the most preferred one.
Detecting a customer. Sorry, I'm not getting the context here.
He just posted which tool is the most preferred.
So it's not a tool driven. So it's like, it depends what your organization or what your strategy look like. So there's a plethora of tools in the market. Okay, some tools are paid, some tools are open source, some tools are like available from your catalog within your organization. If your organization
so he has
is not
posted again, so he wants to know whether we should use R, Python, SAS, like that. So he wants to know in this context.
Correct. So I'm on that technology stack slide. What I'm saying is, it depends on the organization. So if you can afford a commercial license, you would go with a MongoDB. If you can't afford, you will go with some open source MySQL or a document store kind of a database where it's an open source free license. If you can afford the commercial license of the Anaconda Enterprise, which is a very, very rich library, you get a plethora of Python libraries there. If you can afford an Anaconda license, you can go with the Anaconda license. If you can't, you can go any open source Python library of XGBoost and TensorFlow and scikit-learn and all. Those libraries are also available. But what it comes with the commercial packages, you get a more methods, you get a more readily available algorithms. You don't have to create your own algorithms or the calculations, and you also get a very, very insightful results using the commercial libraries. Whereas the open source, you also have the libraries, but those are like open source. So people have contributed to it. So you cannot get a support around it. If something goes wrong with the library, nobody is there to support you. Nobody is there to take care of it. Nobody is able to give you the updates and patches for that. So it depends. What is the appetite you have? If you have appetite to go for enhance it, update it, you can use that platform. From the tools also, you have appetite to go for open source tool, then you can use that tool stack. So in addition, you can have different tools and technology like Ab Initio, DataStage, and Informatica and BI tools. At the same time, development tool side, you have different libraries. You have a free R, you have Jupyter notebooks. At the same time, you have a paid ID as well. Within the language also, you have a paid ID tools and stuff. But most of the languages are free. It's just up to you that how do you want to use those language and implement it.
Okay, so we have one question from Mr. Ankesh. What is the difference between machine learning and general implemented algorithm? And second part of it is machine learning equal to set of algorithm implemented to handle a scenario?
Yeah, so I'll answer the second one first. So which is ML is combination of algo applied in scenario, which is true. Machine learning is nothing but a set of instruction. I would not even call algorithm. I would say you have set of instructions. You have collected those instructions to derive the specific insightful result, and those set of instructions are utilized to derive one particular set of multiple instruction. Now that is called an algorithm. So I mean, it's nothing but an algorithm only. So as I said, I mean, you start with the business outcome. What you want to achieve. So what you want to achieve, you start with that. Then you collect data. Then you cleanse the data, and then when you comes to modeling, right, you start selecting what kind of algorithm or model you want to apply, and then using that model, you compare that data and you derive your result. So to answer your question, yes, machine learning is nothing but applying one or more algorithm and deriving the result set, deriving the output and insightful results. Your first question was, is machine learning and general algorithm, what is the difference between ML and any general algorithm? So it's the same. Machine learning is, you have set of processes which are being governed by the manual intervention or by the human intervention. Now you are trying to mimic that process using a machine, so that the same set of prediction, learning, data set is being used by the algorithm, and that set of actions are done by the machine rather than an individual. So that's where I think you set of instruction, you provide it to a machine, and machine will keep on running it based on its own. That's what the machine learning is. And as and when you get more data, you get more learning, you keep on applying that learning using algorithm onto that machine, so that your machine is enhanced to make a decisioning or a prediction or actions.
Rajan, we are running out of time, so we would take questions if the time allows. You just continue with your presentation for now.
I think I'm done. I just had a one slide which I would like to say.
Okay, so
it's
after
nothing
this,
but
there's some question.
Yeah. Okay. So it's a huge amount of the financial processes and services we deal with. So I'm just trying to depict a typical product journey life cycle. So whenever we want to launch a product, so let's say if we want to launch a business loan or a credit card or a value-added product, when we launch a product, we what kind of a journey we go through. We decide what kind of channels we want to acquire data from, or what kind of channel we want to publish this product on. Then we see the profiling, what kind of data we have, the existing customer management data, we have a pre-approved data, demographic data, we have data enrichment engines, we have different indicators, we have different products. Then when we do the due diligence, which is like once the customer has applied for a product, we look at the know your customers and KYBs and affordability and different scoring. So the score is different from the bureau score. The bank also has their own scoring mechanism. So if the customer has a sorry.
I'm sorry for interrupting.
Yeah. Okay. Yeah. So a different due diligence method we apply, and then we look at the bureau data. We look at the orchestration layer, which is nothing but applying a different bureau data and internal data. We do like onboarding of a customer. So all these elements on all these piles, what you see, all these keywords you see, everywhere you can apply a machine learning, because all these are a different department altogether within the banking. Everywhere you can apply a machine learning model. Everywhere you can apply different algorithms, and that will reduce the monotonous task, that will reduce the operation staff, that will reduce the back office staff, that will also reduce the lot of monotonous effort by the operation staff. So all these places you can keep on applying the machine learning model. That's what I want to highlight from this slide. I mean, then I have a last slide, but I would not go into that, otherwise we'll run out of time. So I'll straight away jump onto Q&A. Over to you, Anshu.
So I think we have only one question left now. So can we align NLP and neural network in financial calculations?
Yeah. So NLP is a different way of assessing. Okay. So NLP is mainly used when you want to interact with a customer, when you want to create something like a chatbots. A lot of time you go onto Amazon, you go onto different sites where now, because there are millions of customers trying to reach out to the customer service, right? You can't afford to have thousands of customer support staff sitting on the other end serving a customer. So that's where a lot of companies have created their chatbots. So that's where you use NLP, natural language processing, because 90% of the time the customer queries, customer feedbacks, customer requests are the similar kind of a data. Customer would come and say my account is locked. Customer would say I can't see my balance. Customer would say my incorrect debit, incorrect credit happened on my account. So those kind of transactions can be dealt using the NLP. So what NLP does is, customer writes in the English language, they assess this input from NLP, and then they give this input to the actual processing system, and the processing system will take a decision using the ML model and providing the output to the customer.
I think we're done with the questions.
Okay.
Okay, so now I would request Dr. Sunil sir to give vote of thanks.
Yes,
Sunil sir.
yes. Okay. Dear participants, thank you for attending the webinar on use cases of machine learning in financial services. We hope that you find the webinar informative and worthwhile. Mr. Rajan Mistry did an outstanding job of sharing his expertise with you. Mr. Rajan, on behalf of Oro University, thank you for sharing and speaking to our student and other participants. We are grateful for the time and effort you took to share your thoughts and experience with all of us. Thank you for your contribution. Please accept our sincere appreciation for the outstanding presentation. Thank you, Mr. Rajan.
Thank you so much. Thanks to our university and thanks to the whole team. Thanks all participants for sparing the time and listening to me. It's been a pleasure sharing my experience.
Yeah, Rajan, thank you for accepting my invitation to be a speaker for the webinar.
Thank you.
Yeah, thank you so much.